Alright, so let's talk about the graphs and summary statistics. Let's return to ABC where the quality engineer is comparing suppliers' fiber strengths to ensure only the strongest materials are being used. She selects 7 spoons randomly from each of the 5 nylon fiber supplier in random order. She takes a fiber strength measurement from each spool. So now, how can she interpret this data? How can she interpret this data? It's difficult to compare groups by looking at the raw data alone, but we can use individual value plot of the supplier strength data to help us. First, let's look at the variation within each group. Consider group 2. Do the strength measurements of each fiber vary? The individual value plot shows variation in supplier tools measurements. Looking at the graph, we can see how widely the spread the value are within each supplier. We call this within group variation because it refers to the variability within a supplier or factor level. For ANOVA, we assume within group variation is due only to random error, inherent aspects of the nylon manufacturing process, such as raw material quality and factory temperature, contribute to this variability in the tensile strength values. This random error is natural and expected. For ANOVA, we assume that within group variation is caused only by random error rather than something unusual in the process. So now let's examine the variation in the strength measurements between all suppliers. Look at the individual value plot of the strength measurements by supplier. So does this appear that the fiber strength differs between the suppliers? From the graph, it appears that the supplier strength measurement differs. Looking at the graph, we can see wide variation in tensile strength measurements between all suppliers. This called between group variation. In ANOVA, we compare between group variation to within group variation to determine whether real differences between groups exist. If the between group variation is more relative to the within group variation, there is a little evidence that the population means differ. On the other hand, if the between group variation is large relative to the within group variation, uh, evidence suggests that the population means are not the same. We must conduct a formal test to determine whether the between group variation is significantly larger than the within group variation. This test will help us decide whether differences we see between group means are due to real differences or simply random error. Let's review. It's useful to graph the data so we can examine the group or factor level means and look at the variation within each group and between all groups. If the between group variation is more relative to the within group variation, there is little evidence that the group means differ. On the other hand, if the between group variation is large relative to the within group variation, evidence suggests that the group means are not the same. Thank you for your listening. In the next lesson, we'll talk about one-way ANOVA.